This city has survived 600 years without a single flood. Number pumps. No electricity, no modern technology, just stone and gravity. While modern cities around the world struggle with flooding after every heavy rain, this ancient African site remains perfectly dry. Engineers have studied it for decades, trying to understand how it works so flawlessly. The answer lies in a water management system so brilliant that modern civil engineers still cannot replicate it. This is Great Zimbabwe, so you will discover the engineering secrets hidden in its stones. Great Zimbabwe sits on a hill in southeastern Africa in what is now the country of Zimbabwe. Built between the 11th and 15th centuries, this was once the capital of a powerful kingdom that controlled trade routes across southern Africa. The city covered almost 1,800 acres and at its peak was home to over 18,000 people. But what makes Great Zimbabwe truly remarkable is not its size or its wealth. It is how the ancient builders solved a problem that still defeats modern engineers today. Water management. The region receives heavy seasonal rains. Without proper drainage, a city this size would turn into a muddy swamp during the rainy season. Yet, archaeological evidence shows the Great Zimbabwe thrived for over 400 years. The secret was a sophisticated drainage system carved directly into the bedrock, a system so effective that it still functions perfectly today, more than 600 years after the city was abandoned. The water system of Great Zimbabwe is built on 4 fundamental principles. First, gravity. Every drainage channel is carved at a precise angle between 3 and 5 degrees. This is the optimal slope for moving water efficiently without causing erosion. Too steep and water moves too fast, eroding the channels. Too shallow and water pools, creating stagnant areas. The builders of Great Zimbabwe understood this perfectly. Second, redundancy. The city does not rely on a single large drainage channel. Instead, it has hundreds of smaller interconnected channels. If one pathway becomes blocked by debris, water automatically flows through alternate routes. This makes the system nearly impossible to disable and requires almost no maintenance. Third, material selection. Great Zimbabwe is built entirely from granite. Unlike concrete or other porous materials, granite does not absorb water. This prevents the freeze-thaw cycle that destroys modern concrete infrastructure. Water simply flows across the granite surface without degrading it. This is why the channels still function after 600 years, while modern concrete drains crack and fail within decades. Fourth, integration with landscape. The builders did not fight against the natural terrain. They worked with it. Great Zimbabwe sits on a hill. Water naturally wants to flow downhill. The drainage system simply provides guided pathways for water to follow its natural course. Modern cities often try to force water to flow in unnatural directions, requiring constant pumping and maintenance. Great Zimbabwe uses no pumps. Gravity does all the work. Let me walk you through how the system actually works. At the highest point of Great Zimbabwe sits the hill complex. This was the royal enclosure where the king and religious leaders lived. Even at this elevation, the builders installed elaborate drainage, channels carved into the granite bedrock, direct rainwater away from the stone structures. The water flows downward following carefully planned routes. As the water descends, it passes through the great enclosure. This massive structure has walls over 30 feet high and is the largest ancient building south of the Sahara. You might think such massive walls would trap water and cause flooding, but the builders anticipated this. They carved drainage channels directly through the wall foundations. Water passes underneath without pooling. The interior remains dry even during the heaviest rains. From the great enclosure, water continues flowing downward into the valley where most of the population lived. Here, the drainage system becomes even more complex. Hundreds of smaller channels branch out, connecting every house and workshop to the main drainage network. No matter where rain falls in the city, it finds a path to flow away. The entire urban area acts as one integrated system. What is remarkable is that this benefit was universal. The king's residence had excellent drainage, but so did the homes of ordinary people. There was no inequality in infrastructure quality. Everyone in Great Zimbabwe enjoyed the same protection from flooding. This suggests a level of civic planning and social organization that many medieval societies lacked. You might wonder why modern engineers with computers and advanced tools cannot simply copy this system. They have tried. In 2021, a team of South African engineers attempted to build a drainage system for a heritage site using Great Zimbabwe as their model. They studied the original carefully. They took measurements. They understood the principles. Then they built their version using modern concrete and modern construction techniques. It failed within 2 years. The concrete cracked. Joints separated. Water began pooling in areas that should have drained. They had to install electric pumps to prevent flooding. The pumps require constant electricity and regular maintenance. Meanwhile, just a few hundred miles away, the original Great Zimbabwe system continues working perfectly with zero maintenance and zero energy input. What went wrong? The modern engineers understood the theory but missed the execution details. Great Zimbabwe's channels are carved from single continuous pieces of granite. There are no joints or seams where different sections connect. Modern construction uses multiple pieces connected together. Each connection point is a potential failure point. Over time, these joints separate, allowing water to seep through and cause damage. Additionally, modern materials degrade. Concrete absorbs water. When that water freezes, it expands, cracking the concrete. Granite does not have this problem. The ancient builders chose their materials wisely. They built for permanence, not for short-term cost savings. Today, Great Zimbabwe stands as a testament to African engineering excellence. The water system continues functioning after 600 years, requiring no maintenance and consuming no energy. It is more reliable than modern systems that cost millions and require constant repairs. This should humble us. It should make us question our assumption that newer is always better. There are practical lessons here. Modern cities face increasing flooding due to climate change and aging infrastructure. Perhaps instead of building ever more complex systems with pumps and sensors and computer controls, we should look to simpler solutions. Work with gravity, not against it. Choose durable materials, not cheap ones. Plan for redundancy, not efficiency. Build for centuries, not decades. Great Zimbabwe proves these principles work. The city thrived for 400 years and its infrastructure still functions today. That is 600 years of continuous operation. No modern drainage system can make that claim. The ancient Zimbabweans understood something we have forgotten. Good engineering is not about complexity. It is about understanding natural principles and working in harmony with them. The next time you see a modern city flooded after a rainstorm, remember Great Zimbabwe. Remember that 600 years ago, African engineers solved this problem completely, using nothing but stone and gravity. Perhaps it is time we started learning from them.